let's look at the question. +1. We are given a large integer represented as an integer array digits, where for each digit at I is the ith digit of the integer. The digits are ordered from the most significant to the least significant in left to right order. The large integer does not contain any leading zeros, so we should increment the large integer by 1 and return the resulting array of the digits. The first example, the array represents the integer 123. Incremented by 1 gives us 124, thus the result should be 124. In the second example, the array represents the integer 4321. Incremented by 1 gives us 4322, thus the result should be 4322. The third example, the array represents the integer 9. Incremented by 1 gives us 10, thus the result should be 10. Let's identify the rightmost digit. When it is not equal to 9, we just increase that digit by 1. Then all the following consecutive digits of 9 should be set to 0. But when we meet all the digits are 9s, in this case, we need to set all 9s to 0 and append 1 to the left side of the array. So if the rightmost is not 9, we just increase that digit by 1 and set all the following line to 0. So this algorithm is just a schoolbook addition with carry. The first step is move along the input array. We starting from the end of the array. It is just one pass along the input list. Since it is no more than one pass, so the time complexity is overflown, where n is the number of elements in the input list. And the second step is we set all 9s at the end of the array to 0. And the third step, if we meet non-9 digit, we will increase it by 1. So the job is done, we just return the digit. But when all digits were equal to 9, now they have all been set to 0. Then we append the digit 1 in front of the other digit and return the result. We operate the element on the input list itself, but when all digits are 9, this is the worst scenario. Although we perform the operation in place, we will need to allocate an intermediate space to hold the result, which will contain the n+1 elements. Hence, the overall space complexity of this algorithm is O of n. Let's try to turn our algorithm in Python. First, we already have a defined function and the printout example as the input. We just need to declare n as our length of the array digit, and we loop inside the end boundary for I in range n. So everything is inside the boundary, and the index is we need to record the index is start from the end. The last one is the n-1, and it should every time it should decrement I. So I is we can print I. I is 0, 1, 2, 3, and if we print the index, it should like this. It's a reverse, right? Yeah. And so if the digit at a index, that means we loop from the end. And if it is a 9, then the digit at the index now will become 0. And else, if there is no 0, we just then index can just add increment 1 and return the digit. And if it is 0, and we should return, or if it is 9, we should return the first element become 1, and we need to add digit. Yeah, that is how it works.